Welcome back, folks. So we're going to take a look at our second half of measuring steepness or quantifying steepness. And in the next couple of videos here, the second day, we're going to talk about how we can compare the slopes of different lines using our intuition. So this intuition, you might have heard that word before, or maybe heard the word intuitive. But really all this means is using our intuition is, using like a gut feeling, or some people say common sense, or just kind of it just feels right. Another way to think of this is again using what we know, prior knowledge, using prior knowledge. And to do that, we're going to take a look at a couple problems here. Alrighty, so here are a bunch of lines, and we're going to work through a couple questions about these lines. So the first question, if we're just looking at it visually, because again, we're just comparing steepness and then trying to put a number to that steepness, which one would you say looks, well, the steepest? And so I'm really imagining, and it's really helpful with these little slope triangles that are drawn, that we're walking up. If we're on here and we're kind of walking up a ramp, and so, well, which one would be harder to walk up? Or I guess alternatively, you could think of it, which one would you roll down the fastest if you tripped and fell down? Well, there's A, but I think again, just looking at it, if B is the side of a mountain, this one is super steep, even more so than A, and I think both of them are steeper than C and D. So I definitely think that the steepest line would probably be, and I'm going to type here to keep it neat, and the steepest probably be B to me, I think. Line B is the steepest. Let's see, I think the least steep, it'd be hard to tell exactly if it's C or D, and I'm not really looking at the numbers here. Now with D, if I'm going up, by the way, I would be going to the left. It's kind of hard to tell because they look roughly the same steepness, just one's going downhill and one's going uphill if we go left to right. And so I can't really tell. If I really had to pick, I guess I would say probably C, but that's kind of just a gut feeling. So I'll just kind of say C or D. Lines C or D are the least steep. I can't really tell really exactly which one is the most flat. Okay, well, what can we say about the slope for D? Because if you think about it, D is actually so far the only one that looks different based on what we've been doing in the last couple of videos. So what stands out? And the reason that I say that is that it stands out because it's actually going a different direction than all the other ones. All the other lines, they're going up as we go to the right, left to right. And again, we usually read graphs left to right, just like we read English. But D goes downward. And so if D goes downward, well, in all the other ones, we've given these like a slope of, so far we've given these a slope of like 1. I know in one video we had a slope of 12. In another one we might have a slope of 3. But the thing is, as we go over to the right, again, or if we think about it in terms of tile patterns, every time we increase the figure number, we're adding tiles. Go over one figure, add 3 tiles. Over one figure, add 3 tiles. If we look at D, we would be taking tiles away. So for example, if we went from this point, this is, I think it's 1, -6, to this point, which is, I think, 6, -8. And so as we go from between figure 1 to 6, we're actually taking away total of 2 tiles. And so in figure D, since we're taking away 2 tiles, I think it would make sense for the slope or the growth rate to actually be a negative number. So since line D goes down as we go from left to right, we would probably assume that the slope would be negative. And again, that's why I'm seeing our intuition, because we haven't actually calculated it yet, but we just know if we were gonna give it a number, it probably is gonna be negative. The slope should be negative, and that's kind of the important part here. Alright, so now we can actually calculate the slope of each line, and I'm just going to do it directly on the graphs here. And with the graph paper, it's kind of in the way, but we'll just zoom in here. And you should pause the video here and take a look at these on your own first. I definitely recommend drawing them, by the way, in your notebook. Okay, so I'm going to assume that you've kind of taken a stab at them already, but I'm just going to work through, I'm going to do C and D, because those are fun ones. So from C to D, remember, I just need to start off from somewhere and then end up somewhere. So that was very vague, I apologize. But so we'll just pick any point, and it doesn't actually matter which one. And we're going to use these handy dandy slope triangles that they already gave us. So I'm going to focus on this slope triangle here. Now notice where they drew their slope triangles. They made the corners of their triangle on what we call lattice points. Again, those are just points that, you know, are corners on your graph paper. It wouldn't really make sense. I mean, you technically could do this to use a slope triangle like right here. The reason that that's difficult is because it's hard to tell exactly where this point is, because it's not on, you know, a corner on your graph paper. So whenever possible, definitely want to use those lattice points. Okay, so let's see. This one's easy because we could just kind of count our change in y and our change in x. So our change in x right here, our change in x, well, we went from x equals 3, it looks like, to x equals 5. So our change in x, or delta x, also known as our run, is 2. And right here, our delta y, or change in y, is just 1. We just went up 1. And so for line C, our slope, again, delta y over delta x, or rise over run, is just going to be 1 over 2, or 1/2. I guess if you want to leave it as a decimal, you could also do 0.5, but we'll just leave it as 1 over 2. Now, with D, this one's going to be interesting. So let's say we went, like we said before, from this point down to this point. Okay, so in this case, if this is where I start, so I'm going to write out specifically where I start and then where I stop. Now, I could actually do this. Since I'm going from left to right on this graph, we said it's going downward. So right here, my delta y should actually, I'm going 2, but not only am I going 2, I'm actually going down 2. And so I think my change in y should be -2. Because again, from this figure to the next figure, or sorry, the next figure I'm looking at anyway, I'm losing 2 tiles overall. And that would mean our change in x, well, we're still going forward in the figure numbers, so that's going to be, let's see, 1, 2, 3, 4, 5. And so the slope for D, our slope is going to be negative, so we're quote-unquote rising -2, which really just means you're going down, you're falling, 2 over 5. And now we can actually work the other way if we really wanted to. So let's pretend, I'm going to do this one in green. Let's pretend I started at this, well, let's just say I go backwards, right? Let's pretend I started here, and then I stopped there. Well, that would just read it backwards. So actually, I'm gonna blow this one up down here. So let's say I went that way. Well, in this case, we actually went up 2 this time. But since we're going right to left, our change in x would actually be -5 because we're going backwards. Essentially, we're going backwards in the figure number, almost like backwards in time. And so our slope, though, would still be rise over run. So it would be 2 this time because we're rising 2 if we go backwards, but we'd be going backwards 5. And in a fraction overall, this is the same thing as just saying negative 2 or 5. Negative 2 or 5. So actually it does not matter if you read your slope left to right or right to left. Alrighty, so I'm not going to work through A and B as well, but your slope for B, I'll just tell you right now, and you're going to want to check your work, your slope should be, your slope should be 3, and also for A, your slope should be 1. So in the interest of time, I'm going to cut this video right here, and we're going to continue on to our next couple questions here, questions D and E, in the next video.